Here, okay. So why we need to use the SNMP? We know all these things. Suppose imagine you are working in a large network that has many switches, router, and dozen of servers, and hundred and thousand of workstation. And it would not be great if you could monitor all these devices somehow. So use NMS, mean network management system, to monitor all these things. So we discuss about different messages sent by the agent and sent by the you know by the manager and the agent. Okay, we discuss about agent and the manager, and we know about, suppose, our network devices like routers, which is these are our agents, and our manager, it can be a server or it can be a computer. It's a software, like it is just like a software. Okay, so at least you need to understand between the manager and the agent. So agent is your router, switches, and the devices. Okay, all the network devices are your agents, because the agents, especially the SNMP, run the application layer. It especially your SNMP, and SNMP and consists of two things. There is SNMP manager and SNMP agent. So an SNMP manager is a software. Please don't get confused with this one. There is a lot of complication, especially here in this material. I try to get rid of it, but sometimes it is a common course among all the technical colleges. They are teaching the same course, and I cannot remove everything because of the common material. Okay, so the SNMP manager, what is this? SNMP manager is nothing, just like a software that is running on the PC or the server. So what is the purpose of this manager software? It will it will just like it will monitor the network devices. Okay, the purpose of this manager software, which is running on your PC or the server, that will monitor the network devices, and the SNMP agent run on the network devices. Okay, like in your routers. Okay, and just let me take the packet tracer, and then I think you will get some better understanding, because sometimes the student, they are confused. The material is confusing. I do agree with you, material is confusing, but I try my level best to make that material simple, but I have some limitation. I cannot remove all the things which is here. See here. So your router, your switches, these are your, what are these? Yes, can anyone tell me what are these devices? These are your agents. Okay, so these are your agents. Okay, so these network devices we call, let me fill the color, because students still they are confused with the SNMP version 1. So these are your agents. Okay, and here, suppose if you are taking some server or the PCs, the PC or the server, anything. Okay, it can be a PC or the server, because there is software which is running here. This is your, let me take some PC here, let me connect it here, because I believe on the practical. I'm a totally practical person, and I always prefer to do the practical, and I love to do the practical. So most of the actually teacher, they have a different way of teaching the things. So I believe that, so if the student, they will see the things, so they can believe it. Seeing is the belief, mean ainul yaqeen. If you will see with your eyes, you will believe it. If you are just listening from one ear and it is going from the other ear, you cannot hold all the information. Okay, so this is just my the way of teaching. So please try to understand here. So this is your, this one, let me select some other color here, let's say this color, and this is your SNMP manager. Here the software, because some software it is running here, some software it is running in this machine. It can be a server or it can be a PC. If you will go there is a MIB browser, if you will see here. So services, sorry, in config desktop, there is a services. So this is the software. Suppose this is a software. Okay, so this software we can say the manager software. Okay, this is the manager software. Okay, which is running on the server, or it can be a PC. You can make your PC as a server. There is no issue. This is just a specialized computer. Okay, so there is nothing else. So what is the purpose of this one? Just to monitor the network devices. So SNMP agent run on the network devices. Here you need to enable the SNMP. Okay, suppose if you need to enable the SNMP, just no. Okay, here just you need to enable the SNMP. Okay, so here the SNMP you need to enable it. Okay, so SNMP agent run on the network devices. It can be a router or it can be a switch. You know, SNMP community string. Once you will run this command, then what will happen? It will enable the SNMP. The agent will be initiated if you are writing. Okay, SNMP like config terminal. Yeah, I'm not going in detail. We already run this one. Okay, so SNMP server community. Okay, so here you can see here the community string. You can say, let's say the community string can be a NM community string. It is a read only or a read write. Okay, we can say read only. You can see now SNMP agent. You can see SNMP agent on the host router is undergo into the warm startup. Did you observe this one? Yes, yes, please. Did you observe? Yes, Allah Said, Abdullah Umar. Anyone can speak up, please? Hello, can you hear me? Am I audible? Hello?
Yes, Mr. Yes, yes.
Okay, please just because sometimes if I'm thinking I'm disconnected, okay? So please, at least you can reply back to me, even anyone, okay? So now you are getting up now. So here we have the agent. So now you can see the SNMP agent. Once you run this command, SNMP server community string, blah, 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 khalas. Now agent is initiated. You can see it is saying SNMP warm startup. SNMP agent on the host router is undergo a warm startup. It means your agent is started now. Okay. So once you are going to start this SNMP agent on your network devices, so there is a database that I just described is called the MIB informational base. MIB stand for MIB stand for management information base. Okay. So here we have the management information base, and so, and the object could be the interface status. Mean what is the objects in your MIB? What are the objects? The object can be an interface status on the router. Suppose maybe it is up or down, and the CPU load, memory status. All these are the object. Okay. So the object in a MIB is called OID. Object in a MIB we called OID. So here we can get the status of each object by using object identifier. So we need to call those object identifier from our management software. Here you can call some management software. Suppose go to this ISO. This is a complete tree. Okay, this is a complete tree. I'm not going in detail because we already seen it. Okay, suppose if you want a system description, this is the OID. OID stands for object identifier. Object identifier for this description. If you need the interface status, suppose if you want to know what is the interface status, interface name, so you can, this is the object identifier. This is the object identifier. Okay, we call OID. This is the OID for interface. Object identifier for DOD. This is the DOD object identifier. This is the ORG object identifier. This is the internet object identifier, OID. This is the value. Okay, if we need to call this object, then we can, this is the object identifier. Is it clear to all of you? Please don't get confused with these things. And so even we discuss about the get messages, set messages, trap messages, okay, response messages, so many things we have discussed in our previous lecture. Okay, so here let me just go ahead with this 3.4 information for notification, because this is the new thing added in SNMP version 2. Information on a trap in SNMP version 1 has been reconstructed in version 2. Okay, so it is reconstructed in version 2 to confirm the rest of the PDU, protocol data units. Okay, so they reconstructed the version 2, the trap information. Okay, and the PDU. So the macro trap type used in version 1 and it has been made obsoleted in SNMP version 2. So this trap is obsoleted, mean it has been abolished, it has been stopped, deleted in SNMP version 2. At the time, enhancement to the specification has been made and terminology has been generalized to notification. In SNMP version 1, they used a trap, but now they modified to notification because this is the most generalized terminology. Okay, it has been added in SNMP version 2. Okay, as the subheading indicate, there are three modules: SNMP MIB object, SNMP trap object, SNMP traps 5, and SNMP sets. Okay, so SNMP version 2 protocol operations are based on the community administrative model. Okay, community administrative model, which is the same as SNMP version 1, as we have seen here. So here we have the community string, so we need a community string, and it is same like in SNMP version 1. Okay, so as see here, so data structure of SNMP version 2 PDU. So this is the protocol data unit of SNMP version 2. PDU data structure in SNMP version 2 has been standardized to a common format for all messages. Okay, so now for all messages, they make it as a common format. Okay, so what is the data structure of SNMP 2 version 2? So this is the data structure and this is the PDU. Okay, this is the PDU values. This is the PDU values. So the improve the efficiency and performance of the messages between the system, it has been improved, and significant improvement is bringing the trap data structure in the same format as the REST and generic PDU message structure. So this is a PDU type, request ID, error status, error index, object value 1. So these are the variable binding. Okay, object value 1, object value 2, object value this. So they have added in the SNMP version 2 PDU data structure. Okay, now the PDU type is indicated by the integer. You can see here, this is a PDU type. Okay, so it is indicated by the integer, and the error status, if you will see here, this is the error status in this PDU. Now we are explaining this one. This error status and error index, you can see here, this is the error index, this is the error status. So this error status and error index fields are either set to a 0 or ignored in a get request and get next request and set messages sent by the manager. Okay, sent by the manager, SNMP manager. And error status is set to a 0 in the get response message if there is no error, otherwise type of the error is indicated here. Okay, so the error index is set to a 0 if there is no error. Okay, so here it is mentioned here, if there is no error, it will be set as a 0. Okay, so the error index is set to a 0 if there is no error. If there is an error, it indicates the first value binding is in the variable binding list that caused the error. Here it will show here. Okay, so this is a first object value and it will show some error message here. The first variable binding is a request variable binding list in index 1, second index, so on and so far. Okay, so this is all about your SNMP version 2. Now let me check what are SNMP version 2 protocol operations we will discuss. So let me finish this one, and then we will go to the SNMP. There are several protocol operation in SNMP version 2. What are the protocol operation in SNMP version 2? Please, this is note down. What are the 7 protocol operation in SNMP version 2? What are the 7 protocol operation in SNMP version 2? So there the message, get request message. Let me take this pencil. This is also, so get request message, get next request message, set request, get response are both similar in SNMP version 1 and SNMP version 2 and operate in a similar fashion. So all this 1, 2, 3, 4. Okay, all these are same like SNMP version 1 and SNMP version 2, but 2 additional messages that are in SNMP version 2. What are those 2 additional messages? 4, this is 5 and 6. 2 messages are the additional. What are those 2 additional messages that run in SNMP version 2? Okay, which is not in SNMP version 1? The first one is the bulk, get bulk request, and inform request. These are the two additional messages are added in SNMP version 2. Added in SNMP version 2. Okay. So the command get bulk request is the enhancement of get next request. Okay. So this is the enhancement of, we are enhancing the get next request with the help of get bulk request. Okay. So this is the additional message. These are the two additional messages are added in SNMP version 2, get bulk request. Okay. And if you can see here, just let me go and okay, I will go there. Request and retrieve the data in a bulk efficiently. So inform request in sorry, this one also, the inform notification, inform request in SNMP version 2. It is okay, just 1 minute. Okay, we will go there. Just let me keep. If you will see here, now this is the service, sorry, desktop, MIB browser, router, ISO, ORG, DOD, internet, management, MIB, system. Now you can see here get, see the get bulk messages. So if you are using SNMP version 2, this is the enhancement, the get bulk messages. Okay, the get next request, get bulk messages, this is the enhancement. Okay, we are getting here. Here we have some limitation, but we cannot do anything with the in the packet tracer. Okay, so now we finish this one. Now we are going to start a new topic here, iOS Cisco syslog messages. So anyone can tell me about what is this syslog and why we need it? Okay, so what is syslog? So okay, what is NTP? Syslog. Okay, what is syslog and what syslog messages look like, and how to send the syslog messages to the buffer in a RAM, to the external syslog server? What are the structure of the syslog messages? So these are the things now we are going to discuss. So can anyone tell me what is the syslog message? Yes. Yes, please.
Protocol.
Sorry. See here now, just I would like to tell you now. So syslog, you can say, is the standard for message logging, and it is used in the network devices. Message logging. Okay, so I will show you with the help of example. That is why I told you I don't want to let you in the theory. Inshallah, I will explain you the by practically today the syslog working mechanism. Okay, khalas, no more, because here especially in the packet tracer we have enough support. Okay, we have enough support in the packet tracer, don't you worry, inshallah. So syslog is a standard for message logging, and it is often used on the network devices. Please keep it in your mind. And syslog show the messages and is able to store them on the local device as well as on the logging server. Suppose you have this syslog server. Suppose, okay, now we will give you the example. Syslog, this is your syslog server. Syslog. Okay, this is your syslog server. Okay, suppose this is your syslog server, and there is some logging messages. Okay, as I told you, so you can store the messages here in the router itself or in the switch itself, but better or the professional way, always store your system generated messages to the server. This is the best practice, but there is no harm to store the syslog messages on the device itself. Okay, so now we are going to discuss about the syslog. If you have heard of the syslog before, you have probably have seen it when you work on a router or the switch. If you will see here, now let me go to the router, enable. Okay, and here show IP interface. brief. 1 minute here. Suppose now here we have interface gigabit 00 and 01. Okay. Suppose, okay, we have these two interfaces. Now, suppose if I'm going to configure terminal interface gigabit 0/0 no shut. No shut. Now you can see it is enabled. Now, can you see, can you take a look and this lines of code, what is this? Yes. Yes, please. Can you? So what is this? These are the system generated messages. It means the link, this is the severity level, and change the interface gigabit 0 to change state to up. See? Line. So you can see these are the system generated messages. These are the system messages, system generated messages. If it is shut down, if it is up, down, or anything happened with your router, with your devices, it will generate a message. Whenever anything interesting is happening on the router or the switch, Cisco IOS inform us in a real time. This is done by the syslog. This is done by the syslog. By default, these syslog messages are only outputted to the console. So this is a console now. Here it is outputted. Okay, these outputted to the console. This is because of the logging console, because here we have a logging console command is enabled. By default, you can disable the logging console. Okay, no problem, because logging console is enabled by default. Because of that one, this is generated by the system, and we can if anything happen with our router or the switch, it will inform us on the real time. Okay, now our interface is up, our interface is down, this thing is happening, and you can see the time is not mentioned. We will see later on time and date and all those things we need to enable. So if you log in through the telnet or SSI, you won't see any syslog messages. You can enable with the terminal monitor command. Okay, so if you will see here, now we can see show logging. Now you can see by this way, you can see the log messages which is generated by this device, which is generated by this device. You can see the log messages. Okay, because this is a network monitoring. Now, if anything happened with your network, it will generate the message. Okay, it will generate the message. So now you can see show logging, because as I told you, your router and switches or network devices, they will store in the local database of the router. Okay, but how much messages it can store? It can store how much byte it will store? Can you tell me? Anyone have idea about how much byte it can store in its local database? Yes, how much in the local database of the router or the switch? Suppose let's say the router. Okay, how much data, mean the syslog messages store in local database or local device database? Okay, local database. Okay, local device database. Let's say local device database. Okay, local device mean the router. How much? Do you have some idea? See, 800 and 8192 byte. 8192 byte of the syslog messages it can store in its RAM. But there is a problem. Byte, B-Y-T-E, byte. Okay, but there is a problem. There is a problem. What is the problem? The problem is when you reboot your router or the switch, the history will be gone. The history will be gone, obsoleted. Okay, so it is possible to increase the size of the logging buffer. you can increase the size of the logging buffer. Let me check. Is there any support here? Show logging. Show logging. Show logging. No, it is only showing the logging messages. See here now, it is supporting 4096 byte logging exceptions, and logging buffer logging. Show logging buffer. I think it is not supporting here logging. LOGG. Show LOGG logging buffer. No, it is not supporting. Okay, so packet tracer is not supporting, but we can do it. Okay, so so you can increase the buffer size as well, no problem. Okay, logging buffer. Let me check. Shall we do it or not? Configure terminal. Just for the sake of learning. Okay, logging buffer. Okay, now you can see we can increase the buffer size 40962. This much of the size we can increase. If you want to store all your system generated messages, yes, then you can store in database, and you can also increase the buffer size of your syslog uh, server. Okay, so increase the buffer size of your device. Okay, so now you can increase. By default, see 4096 is there. You can increase up to this number of bytes. This number of bytes you can increase. Okay, so these number of bytes you can increase up to. See, but it consumes your RAM. It will slow down your router as well. Okay, and but there is a problem. If you are storing all your system generated messages, there is a problem. A local history is nice, but it is stored in a RAM. But the thing is, if you reboot the router or the switch, it will be gone. What if the router crash and you want to see it, if it is logged anything before it or went down? What is the purpose? If you have, suppose, dozen of router, or maybe 10-20 router and the switches, okay, and logging into each device one by one to look for the syslog messages is also not a best way to spend your time. Here we have two devices. We can log in here and we can see the syslog messages. Okay, what are the messages? What are the messages generated by this device, other device, this second device? But if suppose you have 10, 20, 30 or 100 devices in your network, so you will go one by one and you will monitor them? No, this is not a best practice. Go one by one and you can see this system has generated this message, this device have generated this message, other device has generated this message, because it is stored in the local database. So the first problem, as I told you, the first problem with the internal storage in its the syslog messages stored in its internal database of the device. The first problem is, what is the first problem? Anyone can tell me? Problem, issue, if store in same device local database. What is the issue? Yes, anyone can tell me? Yes, I just discussed now. Yes, Amar Khamis, can you hear me? Amar Khamis.
Yes, Mr. Yes.
Yeah, what is the issue if we store this system generated messages in the same device local database? What is the issue? See, I told you, here we have, this is the system generated messages. Okay, so these are the messages. See here, we write no shutdown, and this generate this message. Our router generate this message. Okay, this is a syslog message. Okay, because now we know this is no shutdown, and it shows us. Now here, suppose if you want to again interface gigabit 0/0 and write shutdown, you see here again it generates the message. This is a system generated message. Now as administrator, we came to know this interface has been down, administratively down. So we can take the action. So as I told you, first, it is difficult. Okay, the first problem, because if you have 100 of devices in your network, then it will be difficult for you to manage, because you will go one by one and you will see, okay, this is the message generated by this device, this is the message generated by this device. It will be a difficult one by one, go one by one. This is the first problem. Second problem here, suppose it is stored in a local RAM. But if you reboot the router or the switch, what will happen? If you reboot, okay, reboot means shutdown or restart. What will happen? All these system generated messages will be gone. Alas, you cannot see anymore if it will be reboot. Okay, so these system generated messages, now it is stored in its local database. Now, once you local database means that stored in a RAM. RAM, okay, stored in a RAM. Please don't get confused. It is in a RAM. If you reboot the router or the switch, it will be gone because it was in the RAM. What if the router crashed and you want to see if it is logged anything before it went down? No, you cannot see then. These are the two problems, okay? And as I told you, 100 devices, it is very difficult, very time consuming to go one by one, even if it is not rebooted. So the best practice, always use a syslog server. Always use a syslog server, okay? So if you will use your syslog server, so all the messages which were generated here in this device or any other network device, it will store here. At least you can see what message was generated, what time it was generated, and when this message was logged and when it was logged. Okay, and what happened to this interface or device. Okay, at least you can see. So the second thing here we have, we can see a different severity levels are there. We will see here severity level, syslog severity level. Okay, think about, let's take a closer look at the severity level. There are different severity level for logging the information. The interface that goes down is probably more important to know the message that tell us we exited the global configuration mode. Okay, so there is 8 severity level. We have 0, 1, 2, 3, 4, 5, 6, and 7. These are the severity levels. Okay, so we have different syslog severity levels. Okay, syslog severity level. How many level we have? Total 8 levels. Okay, syslog severity level, there are 8 severity levels. Okay, 8 severity levels. What are those 8 severity levels? The first level we call 0. 0 is our emergency. Okay, and 1 is our alert message. I will tell you in couple of minutes, you will know. Inshallah, alert, ALERT, alert message. Okay, third one is your error message. Fourth one is your warning message. Okay, and fifth one is your notice. And sixth one is your information. And seventh one is the debugging. Okay, so these are the 7 messages. What are these messages? These are the 7 messages. Emergency. So please keep it in your mind. Sometime in MCQs they can ask, lower the number, indicate more important the message is. Is it true or false? Yes, it is true. So lower number, lower, this is lower number. This is lower number. Lower the number indicate the more important the syslog message, okay? Like if it is an alert message, alert and emergency are used when something bad is going on, okay? Something bad is going on, like when your router run out of the memory and the process crashes. This is bad thing happen, na? And critical, this one, error, okay? Critical error and the warning messages are used for the important event like interface that goes down. And I will just give you some example here. If you will see now, see here, this is 5. 5 mean this is a notice. So you are telling, okay, now our interface is going down and this is down and this is the informational message. You can see this is just a notice. Okay, this indicate the severity level. This indicate the severity level. Okay, so this 5, if you will see this one, the 5 for the interface that administratively shut down, it is indicated that this is our notice. But now if we will write no shutdown, now you can see here, now administratively down, and this is again the information. Okay, so by this way, exit, logging, synchronize, logging, sorry, synchronize, logging trap, logging console, okay, logging host, trap, user information. Okay, so now we will configure this server just in a couple of minutes. So all these things, I think it is clear. So now we will configure this one, and let me go and discuss here. Okay, now here we are going to configure this syslog now. Please, you can also open the packet tracer. Please open packet tracer, design this topology. Please do it quickly, please. I will give you 2 minutes. Please open the packet tracer. Okay, so here meantime I'm going to design here. Suppose we have this network 192.168.1.0, and this is our network, and syslog server, let's say I have 192.168.1.10. I'm going to assign this one 1.10. Okay, and here it is 1.11, no problem, and this will be 1.1. okay, so this will be 1.1. okay, so shall I start? Did you open the packet tracer? Yes, please tell me. So shall I start? Yes. Okay, so now gigabit 00. Okay, now let me do it quickly. Gigabit 00, I will directly go to the gigabit 00 here, and let me sign it here. Okay, there is no point to go here and there, just 1.255, no shutdown. We already write no shutdown, done. Okay, we have assigned this IP. Okay, here now our network is configured. Let me do the configuration here as well. This is our syslog server, this is one, and default gateway is 1.1. okay, now done, this is done. And here let me assign the IP here as well. There is no point to add it here, just okay, just to make our network a little bit big, and that is why I'm going to add it here. Okay, so now this is our syslog server. We are telling, so all the message which should be generated here, it should log to this server. Okay, now we will go to the router, and we need to configure, we already configure the IP addresses on the interface, and we configure the PC based on this topology. Now configure the syslog service. So first you need to enable the syslog service, and then configure the intermediate device to use this syslog services. Okay, now here first what we need to do, we need to write config terminal, configure terminal, and here you can write logging. Okay, logging server. So we are telling if any system generated message, you need to log to this server. Yes, we need to tell our router or this device if any message you are going to generate, log to this server. What is our server? This is our server 192.168.1.10. So this is our server. We are telling to our router, log any system generated message to this server. Is it difficult? Easy? Easy. Yes, we are telling, halas, logging. Okay, now this is done. Okay, so this is done. This is one line command. So then go to the server, go to the services. Here, can you check here? So this is your syslog. Click here on the syslog and you need to enable. Okay, this is on or off. Okay, so you should do it. Okay, now see here. Now I will keep this one as a top here. Now we have logging server. Okay, so here host 1, you can see this is our initiated port number 514 started CLI initiation. Okay, now see here, configure terminal. Okay, now if we are going to interface, let's say we can also configure the loopback interface, no problem, but we have already 1 gigabit 00 interface. We will write interface gigabit 0/1. We have one interface now. So this interface we are going to write no shut down. Now you can see here that this message has been logged here. Did you observe? Yes. Now, so you can see host 1.1 and this is the message. The timestamp is not enabled. We will enable the timestamp, no problem. Just for the time being, you need to understand. You can see once you write shut down, now you can see this message has been logged to your server. This message has been logged to your server. Okay. Now, if we write again shut down, you can see another message, the second message, it comes. So this host name like 1.1 is our router and this is the message. If you make it big, you can read. Now, oh, this thing happened to my router. Halas, finished. This thing happened to my router. Okay, good, good. At least you are getting these messages to your server. You are getting all these messages to this server. Okay. Now, see here. So you can also check the severity level 555. Okay, that's okay. Now, but there is no time. No time because we did not configure the time here. NTP we will configure later on. I will tell you just in couple of minutes. So first, let me set the time, local time. Okay, we are setting a local time exit because we did not configure the time. Na? First, we can configure the local time here. Let's say clock set. We can just set the clock set. Sorry, exit. CLOCK clock set. Okay. Now here hours, minutes, and second. Hours, minute, and second. We need to say because here the timestamp is not coming. No? So sorry. Here clock set. So hours. So what is the time here? Let's say 10:58. Okay. Okay. Now it is November. Now month. November. NOVEM. NOVEMBR. November. Today is 18 or 70. Sorry, 18 and 2021. See, we set the time. We are setting a local time here. We are not getting the time from the server. Later on, I will tell you. Okay, how you can set the NTP server. I will tell you in a couple of minutes. Okay, first just focus on the syslog. Then we will go for the NTP. So we have set this time here, and this is the time. Now, if any message it will generate here. So it will also send the time. Okay, before you can see we don't have the time. Now we set a local time here. Okay, so now configure terminal. So we need to examine the event. So first we set the clock on our router manually. Okay, so we can also set the clock and the logging server on the switch as well. Okay, don't you worry, inshallah. I will tell you how you can set that. Okay, because first you need to enable the logging timestamp service on the switch. This is very first. This is the thing you need to do, because you set the time. Now you need to enable this one. Okay, please. This is very important. Service time stamp log. We are saying date time, because date time is not coming here. Na? Did you observe? The date time is not coming here. Okay, so date time is not coming. It is not shown. It is not shown. So we are telling. So you also need to log the date time. We are telling you also need to log the date time. We are telling to the router, please service timestamp. Timestamp. We also need a timestamp. Okay, what time this event happened? Because we don't know. Maybe it happened night, day, evening, afternoon, 1 o'clock, 2 o'clock. We don't know. At least being administrator, if we are managing our network, we should know what time this event happened. If this network is down, how long it is down? At least we should know the status of our network device. So here we need to tell our router. Yes? Anyone? Yes? So now we need to tell our router. So you need to also log date and time. You also need to log date and time. Okay? Date and time in millisecond. Millisecond. Okay? Millisecond. Alas, done. So now we are telling. Okay? So timestamp. Yes, we also need timestamp here, because there is no timestamp. We need a timestamp in our server. This is our syslog server. So when this thing happened, when this event happened, okay, you need to log date time in millisecond. Now, once done, date time is enabled. Now we will go to the interface. Interface, let's say gigabit 01. Other interface. Okay, don't down this interface, otherwise how it will log the message. 01. We write no. Sorry, shut down. Okay, shut down. Okay, shut down and no shutdown. Let's say no shut down. Now you can see here. Did you observe? Now it is telling us the date, time, and millisecond. Okay, you can see date, time. This thing happened at this time. This is a millisecond. 11:1. See here. This is the time. This is the date. 11/18/2021. Our interface get down or up at this time. Now we have clear picture. Khalas. Now we have the clear picture. Now we know this event happened, this thing happened at this date and this time. Being administrator, now we know the date, time, and the event detail. And this is the name of this is the IP address of our router. Okay. This is the IP address of our router. Okay. Clear to all of you? Same thing you can configure on your switch. Okay. Same thing you can configure on your switch. Suppose let me let me assign the IP address here. Let's say 192.168.1.5. Suppose, or let's say 1.2. We are going to assign to this one. Interface VLAN 1. And let's say enable configure terminal. Sorry, configure terminal. You can see this is also the informational messages. Na? So configure terminal interface VLAN 1 IP address 192.168.1.2, and let me do it this one, and 255.255.255.0. okay, but no need to write no shutdown, but okay, we are writing. Okay, now here we also need to do the same step. First we need to tell, okay, so logging, sorry, exit, logging. So logging server. So what is our logging server? This is our logging server. Yeah, this is our logging server. This is our login server 192.168. So I will write. Let me now close this one. Khalas, finished. So I will clear all the log. Okay, clear all the log. Khalas, I have cleared the logs. Now let me finish the this one. Okay. So logging server, our logging server is 192.168. Sorry, 192.168.1.10. Okay, so this is our logging server 1.10. Okay, so our switch 1 we have configured, and we configure the router 1. Okay, okay. Anyone who want to share something, please speak little bit loud if you have some doubt. Okay, if anyone have doubt, so please speak loudly. I cannot hear you. Or send me the message. Let me check, is there any message? No message. Okay, it's okay, it means it's going fine. Okay, okay, logging. Okay, now this is done, finished. Logging server we have done. Okay, yes, please tell me.
You forget write 1 before 60668.
Where 192.168.1.2?
It's here.
Yeah, here. Okay, sorry, yes, logging server. Sorry, logging here 192.168.1.10. Okay, now done. This is done. Okay, okay. So this is our logging. Okay, and this is no logging. Here, let me also clear this on sometime. It will also create no logging. Okay, this one here. This one we need to remove. Okay, just better. Thank you. Okay, and to this one, and we are only logging to this one. Okay, logging 192.168.1.10. Okay, we stop. See, logging host. This is stop. It is stopped. Now here we started. Okay, good. Thank you for reminding me. Thank you for your it means you people are watching carefully. Okay, so now we have done. Now if we will do this way, is it log this message? Yes, it will log the message. You can see here. If you will go there, you will log these messages. You can see here, this is the, where is the syslog? See here you can log the messages on the switch as well. Okay, but you need to do something. Okay, so you need to go to the sub interface and something you need to do it. Okay, suppose show IP interface, sorry, interface show okay, do show IP. Okay, control Z here, show IP interface brief. Now these are the interfaces you have. Okay, so here now let me generate some messages here. Okay, so here we have some messages. I will go there, just 1 minute, and this is our syslog. Now you can see here, now 1.2 they are generating some messages. You can see. Now suppose if I will go to FA021, if I need to make this one down, now you can see I will write no shutdown. It will immediately, you can see it will generate the message. But the problem here is, it will not log the timestamp. Okay, it is not going to log this timestamp. Yes, so the good practice always, you need to write the date and time here. Okay, you need to set the date and time on the local device. Now we are going for the NTP as well. Okay, NTP I'm going to tell you in couple of minutes. Exit, and first we can also configure the, we can set the clock on the switch manually. Okay, there is automatic and the manual is also. Automatic is NTP. NTP we will discuss in couple of minutes. Okay, now we will discuss about how to set the clock on the switch manually. So anyone can tell me set, sorry, clock set, sorry, clock, CLOCK, clock set. Okay, clock set. What is the time now? This is 11. Okay, so this is the format we can use. Okay, let me, this is the format, hours, 11 hours that 50 sorry 11, let's say 10 00 second. Okay, suppose this is a clock set, we are setting clock 11 10 00, and it is November, November, November. Then we need to write today date. Today is 18. Okay, 18 2021. Okay, now done. See, we set the clock. We set the clock on the switch. If anything happened now, so now it will record the date and time. You can see here. Now it will record the date and time now. Okay, so this one is clear to all of you. So now, if the syslog, if you have any question regarding the syslog, please you can ask question. Okay, now we are going for the NTP. We are going for the NTP. See, NTP is basically your, what is NTP? Network time protocol. Network time protocol. So network time protocol purpose, purpose of NTP. So the NTP is used to allow the network device to synchronize their clock with the central source clock. What is our central source clock? Suppose this is our NTP server. We are adding here the NTP server. Suppose this is our NTP. Let's say NTP server. Okay. So suppose this is our NTP server. Okay. So now this is our centralized source clock. Here you can see, go to the services, and here you have NTP. So you can enable the authentication as well. So it will get, okay, this is a time. Now this is it will take the time, date, time from this server. You don't need to set the clock on each and every device. Did you get me? So NTP stand for Network Time Protocol. So Network Time Protocol is basically used to allow the network devices to synchronize their clock with the central source clock. For network devices like router, switches, firewall. So this is very important because we want to make sure that the logging information and the timestamp have the accurate time and date. If you ever have a network issue or get hacked, you want to make sure you know exactly what and when it happened. You can see here, in this case, we don't have the date and time because we need to set each and every device. Think about, if you have hundred of devices, then again, one by one, you will go set date, time, millisecond, all those things. It is again nightmare. So you have a common, because in each device, maybe there is a different time. Maybe you set a different time. But if you have the NTP server, now you have a centralized source clock. This is your centralized source clock. So all devices, if you have 100 devices in your network, regardless of the numbers, think about the big network. Think about it. It means it will get the time, date from this NTP server because this is your central source clock. Okay. And as I told you, if you ever have a network issue, or if anything happened bad, or the network hacked, or anything happened, you want to make sure you know exactly what and when it happened. How you know? Just because of this NTP server. So normally, a router, the switch will run the NTP client mode, which means that it will adjust its clock based on the time of the NTP server. So basically, NTP protocol, this is, the NTP network time protocol. This NTP, basically, NTP protocol describe the algorithm that the NTP client used to synchronize their clock with the NTP server and the packets that are used between them. If you want to see here, NTP See here, this is a good example. If you want to see the cluster of the network, just let me show you here. Google NTP pool, ntppool.org. Sorry, org, ntppool.org. So this is a cluster of NTP server that many servers and network devices use to synchronize their clock. NTP pool, okay. Use the pool. Manage server, you can see here, manage servers. Join the pool if you want to join the pool. So I think better, I will not go how to use the pool in NTP. So all the devices will be synchronized with this one, okay. Okay, leave it. So now our Cisco router and the switches can use 3 different NTP mode. Even your router can be the NTP server, because if you have suppose 10-20 router, one router, if you don't want to make a separate client NTP server, no problem, no issue at all. Even you can make any of the routers. Suppose you have 100 routers, so out of 100, one router can be the NTP server. So all rest of the 99 router will get the time from that NTP router. Okay, so the Cisco router or the switches can use 3 different NTP mode: NTP client mode, NTP server mode, or NTP symmetric active mode. So especially the NTP symmetric active mode is used between the NTP devices to synchronize with each other. It is used as a backup mechanism when they are unable to reach the external NTP server. So now I will tell you how you can configure the NTP server. Okay. Now let me go to the router here. So first, what we can do, we are not using the server, leave it. Okay, I will tell you later on how we can use the server as well. Suppose you want to make this router as a NTP server. 2 scenarios, or let's say, okay, first this scenario we can make it, no problem. Okay, let me connect. So here 03, let me make this one here. So this is our NTP server, NTP. Now we need to authentication. If you need to enable the authentication, then you need to also configure the authentication. In next meeting, inshallah, I will show you how you can also use the authentication. Okay, authentication. So any device in your network, they will get the time, they can synchronize the time with this server if they have this key and password. Okay, so for the time being, I'm not going to enable the authentication, just I enable the NTP services. Okay, see this one, just click it here, and now I need to assign the IP address. Let's say 192.168.1. Suppose let's say 8 is my NTP server. Okay, so this is my NTP server 255, and here my default gateway is 1.1. No DNS, last finish. Okay, now you can see I can easily ping from here to server, ping, and this 1. Suppose 10, you can see now it is okay. Even I can ping to the 1.1 as okay, last finished. Okay, now here I have configured. So NTP server here, suppose if I need to take the time from this NTP server, so here I need to configure. What I need to configure, just let me drag this one here, at least you will get a clear view. Okay, enable, only write one line of command. So enable the NTP service, configure terminal, and write NTP server. So this is our server. The server is, just let me write here, this is our server 1.8. yeah, so I will type the same 192.168.1.10. so our NTP server is this one 1.8. so here we have done enable the logging timestamp with the log that it sent to the syslog server. Okay, we can again enable it. I already enabled, but again, service timestamp date log log date time millisecond. Okay, now done. So we have done. See, WR. So now it will take the time from the server. Show NTP status. Show NTP status, incomplete NTP. Show NTP status. Show NTP status. So if show NTP association, first let me write show and here. Show NTP association. So here the clock is not synchronized. Yeah, it is synchronized offset. Show NTP station. See selected candidate. Okay. Now, okay. So as we see, show NTP association command. It tell us if our clock is synchronized or not. See here, this one. So in front of this IP address, tell us that we configure the server, but we are not synchronized yet. So you can see this because there is no static. If there is no static, it means it is not synchronized. So what you need to do in front of the IP address, the field static should be there. Now here show NTP status. Clock is synchronized. See, the clock is synchronized, statum is true, and reference is 192.168.1.8. Now, if you will write here, now it will show the static as well. Okay. If it is not static, then it will not show. Okay. Sorry, because it will take some time to get synchronized all the device. So here you can see your clock is synchronized. Yes, sir. So your clock is synchronized, and the statum is 2, and this is your server. This is your server. Okay. So what is the server? 192.168.1.8. So this is your NTP server. Okay. So this is your NTP server. And if you will write show NTP association, show NTP association. Now you can see now it is showing the static. Before it was not static because it takes some 1 minute or at least some second it takes just to get synchronized with your server. Okay, NTP server. So this is your router. Okay, so router 0. Okay, so by this way you can configure the NTP in your device. Now we have configured on the router. Let us to configure on the switch as well. Okay, so now if you did not configure it, okay, so configure terminal. Please write down these commands. Later on, please don't ask me, Mr. Upload the configuration. Always write down by yourself. Okay, so configure terminal, and what is the command? So how we can enable the NTP service? Yes, any one of you, please tell me. Yes, Ammar Khamis, Abdullah Umar, can you hear me? Ammar Khamis.
Yes, Mr.
Yes, tell me now, please. Now I had already done the NTP here. Now we need to configure the NTP on the switch. What is the command? Yes, tell me now. What is the command? What is the command to configure the NTP? How we can configure or enable the NTP services on the switch? Yes, please tell me.
Trunk mode.
Yeah, no, here, now what is the command? Because here I already configure on the router. Now we also need to configure the router, okay? Sorry, in the switch. So in the switch, what is the command? How we can enable the NTP services here? Yeah, what is the command? Tell me.
NTG01.
Yeah, NTP, good. NTP server, okay? Yes, NTP server. After that, we need to write the IP address 192.168.1.8. So this is our NTP server, because we need to synchronize all the devices with our centralized server. Okay, it will, all the devices will get the time from this one. Okay, we don't need to set the time on each and every device. Alas, no need, no need. Okay, and if we set each device have a different time. So if we will synchronize with a central server, alas, finished. No need to think about whether we have a different. No, we have the central server. So all devices will get the time from the NTP server. Okay, so NTP server. So IP address 192.168.1.8. Okay, done. NTP server. Also, we need to write, we already done it, services timestamp, because enable the logging timestamp service on the switch. So we need to enable this one by using this command, service timestamp. This is it is used to timestamp, logging timestamp on the switch or the server or the router or any network device. Timestamp, log date time millisecond, date time millisecond. Okay, so this it will do, it will enable the logging timestamp service on the switch. Okay, so once we will done it, now we need to check whether it has synchronized with our NTP server or not. If we ask you, okay, please write the NTP, configure the NTP and take the screenshot whether it has been configured or not, whether it is synced with the with your NTP server or not. Just take this one, show NTP status. If it is the status is unsynchronized, it means it is not synchronized, because the start time is 16, no reference clock. See, no reference clock. But in the same case, if you will go there on the router here, if you write show NTP status, you can see here the clock is synchronized. Yes, here clock is unsynchronized. This is the switch. So you need to take this screenshot, clock is synchronized and the router, this is the complete. Okay, but here it is not synchronized because we just configure it. It will take some little bit time, at least 1 second it will take just to get synchronized. Okay, so it should show this message, the clock is synchronized. It is, clock is synchronized with whom? This is our reference. This is our reference. Here there is no reference, no reference for clock. Okay, so now again, because we just configure it, show NTP status. Now what it is showing? Yes, Abdullah Umar, now it is synchronized or not yet? Yes, tell me. Abdullah Umar, can you hear me? Abdullah Umar? Abdullah Umar? Abdullah Umar?
Yes, Mr. Yes.
Yes. Okay. See here, Abdullah Umar, see here. Now the clock is synchronized. See, before it was unsynchronized. Now here it is synchronized because we configure the NTP, our start time, and this is our reference point. You can see this is our reference. This is our reference. Okay, our reference is this one. This is our NTP. Okay, so that's all for today. And by this way, you can configure the NTP and syslog. Okay, so now I'm going to summarize it. So the first, the syslog, we have configured how the system generated messages are logged on the syslog server, and we also discuss about how we can configure the NTP server. So what is the NTP stand for network time protocol. So basically the basic purpose of NTP is just to synchronize the network devices with its clock as a central time server. Okay, so